Welcome to the Pre-Calc Summer Supplement Lesson 3 Part 2, and this is the final video segment, so you are almost finished. Make sure that you do complete all of the problems that go with these lessons. There's no way to know if you actually get it until you do the practice problems, and you'll find a few additional little tricks and things as you go through them. So please make sure that you do complete all of the assignments that go with all three of these lessons. All right. Yes, the last lesson we had taken a look at equations. Inequalities with rational expressions provide their own unique challenges. Because the negative values are going to reverse the signs, we don't know where the negatives are going to show up because we're dealing with variables. Sometimes they'll be positive, sometimes they'll be negative. So test points are going to be the indicator to determine which part of the graph is shaded, and then we'll use the graph to determine your final answer. Denominators also can exclude certain values from a solution. Remember when we looked at your equation, sometimes a denominator came up to be 0, and that does provide a problem. You can't have a 0 in the denominator, so once again you will end up with some exclusions or some holes in your graphs because of the zeros that could possibly come up. So we're going to look at a series of steps to help you solve these inequalities, and just bear with me. I'm only giving one example, but all the steps will be the same. You have to make sure that you follow them though, so you may want to go back through each step with each problem to make sure that you've found all of the correct division points and you found all of the regions where a graph should be shaded in or not shaded in. Okay, so let's take a look at an example. Here's an example of an inequality. X minus 2 over x is less than x minus 4 over x minus 6. So the first thing that you want to do is just change it to an equals. We're going to do that because we need to find the dividing point on the graph. Sometimes when you have rational expressions, as you know, sometimes you're going to get one answer, sometimes you're going to get two answers. You may turn out with a quadratic to deal with, and that's all fine. This particular one will give us one dividing point, but it's not at all unusual to have two dividing points on the graph. So if you come out with an x equals something or an x equals something else, just realize that you're going to have two dividing points on the graph, and then you'll have more different regions to check as far as figuring out your final answer. So we're going to first of all turn it into an equal and then solve the equation normally, just like we did with the equations that we dealt with in the first part of this lesson. So let's take a look at normally. We find the least common denominator. In this case it's x times x minus 6. Then you multiply both sides of the equation by that least common denominator. Cancel out what can be canceled. Then you've gotten rid of the denominators, so you rewrite it so you can see it better, and you begin to simplify. X times x, x squared. X times negative 2, negative 2x. Negative 6 times x, negative 6x. Negative 6 times negative 2 is positive 12. And distribute this x, so you get x squared minus 4x. Then the wonderful thing about this one is that the x squareds actually do cancel out. You can subtract them from both sides. You can simplify. Negative 2 and negative 6 gives you negative 8. You're left with negative 4 over here. Add 8x to both sides and divide by 4 and you get 3. Now this is not the solution. We still have quite a ways to get to the solution, because remember, it's not really an equation. We just use the equation as a step in the problem. This will give us the dividing point on the graph. You know, whenever you have an inequality, you can graph on a number line the solution. So we're going to set up a number line and make sure that we include 3 on it and some points to the right and to the left. There's our number line. We've got 3 on it. We have our dividing point that is the number 3, and we begin to check points to find out what is included in the solution and what is not included in the solution. So the first point we should check is this x equals 3. We're going to do that check to make sure we haven't made any mistakes. So you're going to plug the x equals 3 back into the equation just to make sure that this work didn't have any mistakes in it. So I say check the split point or points. Remember, I said you may get 2 different split points here, especially if you have a quadratic. So that's going to be your first step. So we plug it in to the original equation, 3 minus 2 over 3, 3 minus 4 over 3 minus 6. They both do give you 1/3 when you're done, so your split point's correct. We want to put it on the number line, but because this original did not say or equal to, it's going to be as an open circle. It's a dividing point, but it's not actually included as one of the answers. If we had or equal to here, with the extra little line under, it would be a shaded in dot. That shouldn't be new to anybody as far as the idea of open circle or closed circle. But since we're dealing with a more complicated problem, you need to understand why it's an open circle here. And this checked 3, so we're going to put an open circle on 3. Now after we've done that, we need to choose a point on either side of the split point to see where the solutions lie. Now if in some way you manage to accidentally pick a point that gives you a 0 in the denominator, you're going to pick another point in that zone. But you're going to make a mental note of that point, because that one will punch a hole in your graph later on. So we'll take a look at them in a minute. So let's pick a test point over here. I'm going to pick 1. You could pick any number over here to the left of 3 and plug it in to see what you get, but I just picked 1. So we plug that in to the original inequality. Now we're going to leave it as the inequality this time, because we're checking to see if this answer, when we plug a 1 in, is going to be less than this one. So we solve it, and we find that this turns out to be -1, this turns out to be 3/5. And so -1 is less than 3/5. That means that our test point is in the shaded in region of the graph. So we're going to shade that whole region in on your graph. That means that 2 and 0 and all the things, all the millions of points over here would have also given you true results. And so we shade that in. Now just to make sure that we were right, we're going to pick a point over on this side as well. I'm going to pick 5. It's just there, it's easy to see, easy to work with. We plug that number in. Everywhere you saw an X, we put a 5 in. 5 and 5, 5 and 5. Simplify them. Is 3/5 less than -1? No, it's not. So this confirms that we've got the correct side shaded. But we're not done yet. The problem is we have some denominators that are not allowed to be 0. So we need to check and see if there are any exceptions, any holes that will be punched in the graph on your shaded region. So let's look for these holes. We look for the holes by setting each denominator equal to 0, because we know if we had a 0 in the denominator, that would give us an exception. That's what this is. We do this by setting each denominator equal to 0. We'll start with this one, x equals 0. So this is the first hole that we found. We don't even have to do anything to solve it. Just that x equals 0 gives us something that just isn't going to work. So we need to punch a hole right here where x equals 0. So we're going to do that. We basically unshade that. That's why it's always good to work with math with a pencil. We punch a hole in the graph right there because x can't be 0. It's everything less than 3, but 0 is a problem. I'm going to check for this one to see if we need to punch another hole in the graph. X minus 6 equals 0, but x is 6. Well, that doesn't give us a problem because it's in the unshaded zone anyway. It would be an exception, but it's already not an answer, so we don't have to worry about that one. So finally, in order to come around to the actual answer to the problem, you look at the graph you made. After you've gone through, you've tested points, you've looked for exceptions, and then you write what this is telling you. Okay, so we'll clear out all this. We use the graph to write the final answer. So the answer is x is less than 3, but x can't be 0. X is less than 3, but x is not equal to 0. Then you're finally finished the answer. So between a combination of your algebra skills and the correct usage of a graph, you do finally come around to the right answer for these inequalities. They are a little bit trickier. They take a little more time. You need to be careful if you come out with 2 different test points or 2 different division points. You might have several regions. You may have 3 regions to check. So as you go through the practice problems, go back and forth between your work and the solutions to work it out, to practice, to make sure that you're working through this concept. You will see it again when you get to pre-calc. Maybe not in the first chapter for this one, but the other things that we've done in the whole rest of this summer supplement come right along in the first chapter. The equations for sure are in the first chapter, and it will be your job to make sure that you study well so that when you see it and it's gone over again, it's not the first time that you're seeing it. You want to make sure that you're careful with notation. I believe next year notation will be important. The exceptions are important. So make sure that you've done every problem. Do your best to understand it. It wouldn't necessarily even hurt you to bring it with you so that when that section comes up, you can ask questions as needed. All right, well, you've finished up the videos. That's great. Now you need to finish up your problems, and I will look forward to seeing you all next year. Always feel free to stop by. God bless you and have a great rest of your summer.